Hey everybody! Oh my gosh, can you believe it? We are here with Soil and the Environment, the last lecture of the semester. And it comes at a great time, actually, because this is the time of year when we start seeing the early crops come in. Um, Obviously, thinking about food, we all need food to live. Food is not only necessary for our survival, but it's something that most of us tend to enjoy. A lot of us consider ourselves foodies, love to experience new things by way of food. And so that brings us to our last topic, that is soil agriculture and the environment. Talk about a lot in here. There's a lot of information on this particular topic, and all the different challenges that raising plants and animals for food puts, the environmental pressures, the pressures it puts on the environment, and what are those particular solutions as far as maintaining a sustainable model for the production of the food that we eat. Whoops, get rid of that. There we go. Okay, so we used to be hunter-gatherers for a very long time, as long as humans have been on this earth, Homo sapiens. I can't remember the exact, 100,000 years or so as far as Homo sapiens. We used to just, roam around and gather the food that we needed and hunted the food that we needed. And it was about 10,000 years ago that we figured out, if we planted a seed, that we could grow a plant, and kind of around the same time that we could domesticate the food, or domesticate the animals that we intended to eat. And so we became an agrarian society. We practiced agriculture. We didn't have to roam around. We could form communities around these particular practices. And fast forward, 10,000 years, and we have to now view our these activities in a way, or practice these activities in a way, so not only do we optimize the environment in practicing these methods sustainably, but also make sure that everybody has enough to eat. Because we have a whole range of topics when it comes to how raising food affects the environment. You have soil, as far as maintaining the nutrient level of soil so it can actually grow food. You need water. You need, well, you do need soil to maintain its nutrients and to minimize the amount of salt. And so we have to balance the need to maintain nutrients in soil and not depend upon fossil fuel-based fertilizers in order to do so. What do we do about the plants that are not wanted, as well as the insects that are not wanted as in our agricultural areas, and then maintaining genetic diversity. So there's a lot to unpack here, so we'll just go ahead and get started. Where do we begin? Well, let's chat a little bit about, well, what is soil, and why is that soil so important in this process? So you have layers of rock. Some are exposed on the surface of the earth, and other bedrock is underground. And as this bedrock erodes, it gets into finer and finer particles like grit and sand. But when you have organic material that dies and decays, it mixes in with this these tiny particles of rock, this organic material, and then you have bacteria mixed in, and you have protists and fungus, and then what you have is soil. So the earth, it's part of our an ecosystem service. The earth makes soil. It can take a long time to make soil. Sometimes an inch of soil can take decades to form, sometimes even hundreds of years. And you see on the upper right-hand corner that there are different layers to soil. You have bedrock towards the bottom, and then parent rock, subsoil, surface soil, and then organic material. And depending upon the particle sizes, whether you have clay or silt or sand, and depending upon how much pores or how big the pore size is, as far as allowing there to be gas exchange and water absorption, how good the soil is depends upon the ability for that soil to produce the crops that we need. My dog is snoring, just so you know. That's the sound in the background. Yeah, there she is. Okay, that's not me snoring. That is her. So you need good sound soil in order to, that is a mixture of organic material, dead fungus, bacteria, protists, nutrients, and the eroded small particles of parent rock. You need good soil in order to grow plants in general, of course, but we're confining our discussion here to the plants that we raise for food, crops. Okay, so let's tackle these one at a time. When you have bare soil, which has been traditionally the way that wild areas are prepared to grow the crops that we need, that's removing the vegetation and then planting the seeds of the plants that make up our crops, you have the problem of that soil being blown away or washed away. Erosion that occurs. And erosion is actually a very big problem around the world. The erosion of soil, in fact, it's mentioned just for an inch of soil, it can take decades, if not a century, for nature to produce soil, and it seems that it is eroding 10 times faster than it can be replaced. An inch is lost every 15 years. That is to erosion, whether it's wind erosion or whether it is water erosion, just washing that soil away. Huge problem, because you need soil to grow crops. You need soil to grow plants, but you need soil to grow in general, but to grow crops. And we see in this country, not as much, but in other parts of the world, this a desertification that is where you have thousands of square miles every year that become basically useless in growing any plants at all. They basically become deserts due to this erosion. Now, that is the problem. We have the solutions on the same slide. We have in our country a soil conservation service, which was put into place to form and implement strategies to prevent soil erosion. If you look up the Dust Bowl back in the 1920s and 30s, where we had so much erosion take place of the topsoil in the middle of our country. And the middle of our country is key to producing most of the crops in our country. So you do have laws and legislation that are put into place, this agency, the Soil Conservation Service. But different ways of combating erosion, not just in our country, but all over the world, seeing as you have water and wind as the primary components of erosion, just the physical removal of soil. Contour farming, that is if an area isn't perfectly flat. What used to be done is you would have the furrows would actually run, which to me just doesn't make sense, but there must have been a reason they used to do this. They used to run up and down mountains, straight up and straight down and straight up and straight down. And so when you'd have some sort of a water event, it would just wash soil away, the water. Whereas contour farming is you actually would plow horizontally to that elevated surface. And so when you did have a precipitation event, when water would run down from a higher elevation to a lower elevation, and now it like gathers in the furrows. So it doesn't wash that soil away, it's actually captured. So that's actually, contour farming has been done for quite a while. Terracing, you see these when you have really steep terrains where you have terrace farming, where they look like little shelves, like stairs, where you'd have flat areas, and then a vertical drop and then another flat area. And this keeps, just like contour farming, but on a more pronounced scale, it keeps the water from running down the side and taking the soil with it. Intercropping is, traditionally you would have, what's the dog? She's snoring. Traditionally you would have, a row of plants, and then in between would just be bare soil, and that soil is prone to being blown away or washed away. And with intercropping, you would actually have something in between those rows to hold on to and secure the soil, whether it's like clover or grasses. Shelter belts and windbreaks, you see on the lower right hand corner, is, in very, like, if you've ever been to the Midwest, it's really flat, and it sounds so dumb to say that, but when you go there, it's you kind of look and you're like, oh my gosh, look how flat it is. It's just so flat. And you have like uninterrupted horizontal wind patterns that blow soil away from these thousands of acres of crops. And so you would plant lines of trees and lines of or shrubs, and what that would do is that would slow that horizontal wind down at surface level to the point where it wouldn't carry so much soil away. And then one thing that's catching on more and more is no-till farming. What farmers often do, still do, is they turn the soil over, and you see this in early spring, is like a field, an agricultural field, the soil is turned over, like dug up to create more, more pores in the soil, aerate the soil, and the furrow lines for the seeds to be planted. And what they do now is they just don't do that. They don't turn the soil over every year, and they don't make these furrow lines, and they just kind of basically poke holes in the soil without it being turned over. And so that freshly turned over soil is prone to erosion. And without tilling that soil, they would just put holes in the soil and then plant seeds in the ground that way. So these are very effective ways of preventing the damage that's done by the physical washing away of soil, or that is soil erosion. Now, as far as soil is concerned, soil that stays in place is awesome, but soil has nutrients in it that plants need. That's where they get their nutrients from, not only their water, but their nutrients. And that renders, if a soil has very few nutrients, it's basically useless. And also, along the same lines, as far as soil being ineffective for growing plants, you have the buildup of salts in soil. So, planting something over and over again depletes the soil of nutrients. And the way salts build up in soil, if you remember from the water lecture, is that when you irrigate plants in the traditional way, crops in the traditional way, and water is sprayed up into the air, that a lot of the water evaporates, but the salts that are dissolved in water are left behind and build up in the soil, and that buildup of salts also renders soil unusable. So what do you do? You cannot overwater. Let me just check something. Whoops. Okay, good. I'm pretty sure I had that slide, sorry. As far as the solution for salts is not overwatering. There you go. That's the way to do it. Or you, oh, these are the challenges. Oh my gosh, forget it. Yes, that is how you wind up with too much. There we are. Okay, should have just stuck there. As far as how to keep too much salt from building up in the soil, you use drip irrigation instead of conventional irrigation, which doesn't allow that water to evaporate. And I don't have that on this slide. Okay, just so you know that. No. Oh yeah, okay, I do have it. Okay. I don't want to start this over. I'm going to keep going. All right, so as far as maintaining nutrients in the soil, crop rotation. Oh, this has been done for quite a while, and that is there are some plants like legumes that have nodules on their roots that return nutrients to the soil. And so, like for every, and I don't know the exact number of years, but like if you're growing corn in a field for 2 or 3 years, like the 4th year you would just plant soybeans, which is a legume, and you would just, you would harvest the soybeans and then plow the plants under, and this returns nitrogen back into the soil naturally. Inorganic fertilizers, which can cause a big problem as far as while they may return nutrients to the soil, we saw in the water lecture as well as the lab that you did that too much inorganic fertilizer can actually cause problems with eutrophication. So we would say to reduce this usage of inorganic fertilizers. And as far as in crop rotation is concerned, also the implementation of organic fertilizers, natural fertilizers, it's a little more tricky on a large scale, but can be done. I know that the Rodale Farms in Kutztown, it's in an experimental farm, organic farm, and they've shown that this can be done on a larger scale, using compost, using manure, using bone meal as far as fertilizing to reduce the amount of petroleum-based fertilizers that tend to be overused. As far as, and this was in our water lecture too, is that you plant to the climate. You don't have those types of plants that use a lot of water in areas that naturally don't get a lot of rain. You would reserve like the more arid areas for crops that have evolved to be in areas where you don't get much rain, and you cut down on irrigation. This would help reduce the amount of buildup of salts through irrigation. And also there's, some things which are deemed somewhat experimental, but are becoming more and more done on a larger scale, and that is hydroponics, not using as much land and as much soil to begin with as far as growing food crops. That is, hydroponics is where you would just use water, nutrient-laden water as far as your growing medium, and you wouldn't use soil at all. Now, there are challenges, environmental challenges using pesticides, whether it's an insecticide, an herbicide, or a fungicide. Now, when you're growing so many so much food, like at such a large scale, that inevitably you're going to have issues and challenges with, you know, the foods for being grown for humans, but lots of other critters that find it tasty too. So, you know, you can have many issues as far as insects are concerned. Um, you also have issues with, you don't have a target, that you have lots of weeds, non-targeted plants that are growing in areas where it is intended to grow food. And then you also have different types of fungus that are pathogenic, which can destroy a crop. But a lot of these pesticides can have side effects as far as causing health problems in people and the environment that surrounds it and the soil. So we do have to find solutions for minimizing the amount of pesticides that are used in the production of food. Now, pesticide resistance, this is, as you see, that's a great graphic on the lower right-hand side, as far as, with the chemicals that you use during year one, in order to reduce, like this has insects as the example. This is just natural selection. This is evolution in action. Is you may have some of those variants in the population of insects that you're targeting that are resistant to that particular crop, that particular pesticide. So let's just say what's shown in the graphic is that, two of those, looks like grasshoppers, survive an application of pesticides because, they just are genetically predisposed to be resistant to it. And then it's those that survive that pesticide that go on to breed for the next year. And they pass on those genes that made them resistant to the pesticide. And then all of the offspring are resistant to that pesticide. And you see in step 5 that pesticide is applied again and doesn't kill any of them because they're all resistant to the pesticide. Again, that's natural selection. That is evolution in action. And so you have to then develop stronger and different pesticides, which can pose to be quite a challenge, in our environment. So we have some solutions to this. You have, from the standpoint of fungicides, herbicides, and insecticides, organic practices are put into, have been successful as far as not using pesticides on crops. And so what are some of the strategies when it comes to not using pesticides, not using these herbicides? Actually, crop rotation is one that is used and has been somewhat successful. It's great for replenishing the soil, but crop rotation and using different crops has been shown to cut down on the amount of pests that are present because the same insects don't come back year to year. Does that make sense? Yeah, it does. But it has been shown to actually cut down on the need to use so many, especially of these insecticides. You can use biological pest control. You talk about, we see this with getting rid of weeds in agricultural fields, that you have, like for instance, using goats in wineries that eat the weeds, but they don't eat the grapevines. You cut down that way. That's a great way as far as biological control, and then the waste that they leave behind help fertilize the grape vines. The release of other insects that don't eat the crop, but eat the insects that are eating the crops. So that's been shown to be successful. There is a method of, it's called companion planting and mixed cropping, and this can be done on a large scale. And that is that there are plants that are not, it may or may not be, I should say, used for food, but naturally deter pests, and then therefore they're planted along with the targeted crop. Um, like marigolds, for instance, that smell can deter other pests from going in to the tasty stuff. But then you have like a clover and nasturtium, which will lure away pests. They're an easier target. So instead, like insects will go to them instead of to the target um, crop. A mint is one that keeps animals away. Now, there are some that you don't want to mix because one might take on the flavor or this of another. There you can see the companion planting chart. So these have been shown to be successful. Now, the one that is somewhat controversial in some circles are genetically modified organisms, and that is where you have genes that are inserted into a genome of an existing plant. Now, this has been done for a long time, since the 1970s, to grow like bigger, have a bigger yield or a better crop. But these are genes that are inserted that are then make that plant naturally resistant to fungus or naturally resistant to insects. And so the like you see there, the example of the bacteria genes that are inserted into cotton plants, and then that cotton is toxic to insects, and you don't then need to apply the insecticides to cotton because it is a genetically modified organism that naturally resists that. As far as raising animals for food, this is a tremendous toll, takes a tremendous toll on the environment. The conventional current way, it's often referred to as factory farming, as far as raising animals for food. 56 billion animals are raised and slaughtered yearly for food, and it has increased 5 times since 1950. Americans eat a lot of meat. Generally, every meal in the American diet has meat with it. And in order to raise animals for food to satisfy the American palate, American diet, we have to do so and have it be cost effective. We have to do so in a very concentrated way. We have these high density food lots, which are notorious for the pollution that is produced in these, whether it's water pollution or air pollution. And you also see, like for instance, chickens that are raised for food, pigs that are raised for food in very tight and inhumane conditions as far as the welfare of the animals themselves. Now, raising food, because you're eating higher up on the food chain, raising food for meat is very inefficient from raising, animals for food is very inefficient in energy because it takes a lot of food to feed the animals that you're raising, but also a lot of water too. We have 441 gallons of water and 20 pounds of grain just to produce 1 pound of beef. So there's a lot of water usage, and that is used to raise animals for food as well. We see the fish stocks, the wild fish stocks, are plummeting. They say the oceans could be relatively barren of any fish that we're feeding, that we're fishing for commercially by like 2050. That's not that far away if we keep going at the rates in which we are as far as fishing is concerned. And when we think of aquaculture, as far as raising fish in some sort of a captive environment, these can cause a lot of water pollution. as well. So wow, there are a lot of challenges as far as raising food. I'm sorry, for raising animals for food. So what are some of these solutions? Now, almost all of these are personal stewardship initiatives. So that doesn't say that they're not effective and that they're not worth doing. It's just that, you know, the more people that engage in these behaviors, like every little bit counts, like collectively every little bit counts. So what can you do? You can, if you want to just go all out, you can just stop eating meat. And there are reasons, or the environment and the environmental toll that raising animals for food takes on the environment is one reason why what people cite when they decide to stop eating meat. There are other reasons people stop eating meat. For animal welfare, for health concerns. Not saying that a vegetarian or a vegan diet are all 100% healthy, because you can eat French fries all day and still be vegan. You have to do it the right way, but certainly there are um, healthy ways to stop eating meat. But people, again, they cite many cite the environment and environmental concerns as why they stop eating meat, and that is really, really admirable in my book when it comes to the environment as well as the welfare of animals. But if that's not your game, if you're not ready to give up eating meat altogether, just slowing down a bit, switching to a bit of a more plant-based diet. There are initiatives that Meat-Free Mondays is one of those, or Meatless Mondays. I think that's the one that catches on in the US. Meat-Free Monday is a UK initiative, and that is where you just, one day a week you don't eat meat. That's it. Could you give up meat for one day a week? And along the same line, some people don't eat meat until their dinner meal. Like they'll be meatless for all their meals except for one during the day. Mostly people pick dinner. So cutting back on the amount of meat you consume, certainly. If you eat meat, you can eat those that are considered more energy efficient, like for instance chicken. Raising chickens is more energy efficient pound for pound than beef. Goat is very energy efficient apparently. That is something one can do. There's also, which isn't on here, but and we saw that film, I think the first or second week of class, is that choosing, when it comes to fish, choosing sustainably raised seafood. If you're looking for, when we talk about wild fish stocks plummeting, choosing to eat lower, or choosing to eat fish that are only sustainably caught, so you're not making that huge environmental impact on the environment. Also, because these high density food lots are take such a toll on the environment, choosing grass-fed or free-range farmed animals, going to your local butcher, your local farmer's market, and buying from there, that lessens it. It's only, for instance, for a pound of beef, whereas if it's raised in a food lot, you see it's 441 gallons of water for 1 pound of beef. It's only, I can't remember off the top of my head, I think it's only maybe 10 gallons of water for every pound of meat from a cow, beef. But nonetheless, free-range farmed animals. And people often cite choosing free-range for animal welfare reasons as well, because the animal has a better life idea before it doesn't suffer before it's ultimately slaughtered for food. And it's not really in this country, but many other countries, they turn to other protein sources like insects Um, Not something I would do personally. I don't know. Maybe I just don't have an open enough mind. But insects are very high in protein and don't take a toll on the environment. Hey, it's one of those things people tell me, don't knock it until you try it. Some of these are delicious, and I don't eat meat anyway, so for me, it's not either or. I'll just take people's word for it on that. Okay. We have um, this time of year and throughout the summer. I guess I'm giving so you'll see this in April, but uh, we live in the Lehigh Valley, which is a very kind of agricultural area. We have lots of farms and lots of farmers markets. We even have one here at NAC. And from an environmental standpoint, this is a really awesome thing because when it comes to the environment, we have this concept called food miles. And that is like you go to a Wegmans or a Giant or Weiss's or ShopRite and you see all sorts of food from all over the world, produce, kind of focusing on that, which is really pretty cool, you know. You can buy bananas in January. You could buy bananas year round. They're not from the Lehigh Valley. They're from thousands of miles away. These food miles, so we call, in order to transport food from one place to another, it does take a lot of fossil fuels and takes its toll on the environment. Um, This can also, fossil fuel use contributes to water pollution and air pollution, and then the digging up of those, the coal and the oil, it's needed to transport these goods to the supermarket. But if, any supermarket around here, they say the average is about 1,500 miles from the source of where that was grown to your plate, and that does take an environmental toll. So what are the solutions here? Well, as I just mentioned, buying local and in season whenever possible. We do have lots of farmers market in this particular area. Along those lines, becoming a part of community supported agriculture or part of a CSA, whether it's what you do is you formatted wrong this slide actually because this is explaining this is that you actually you pay a flat fee if you don't have the means of being part of a community garden where you tend to your own plot or having a garden in your backyard, which you're definitely tending your own plot, you'd pay a certain fee to a farmer, and I don't know how much it is. Just for round figures, you pay $100. That seems really excessive, but you pay $100 and then you actually get a part of what they grow. You pay them advance and then you get part of what they grow. So solutions, buy as close to the farm as you can in order to reduce the number of food miles that and toll on the environment in your food choices. Now, this is a one that uh, involves more experimental procedures, because we talk about solutions, we talk about the big things, the big initiatives that we can practice as a culture, as a country. And then, we talk about these cutting edge initiatives, which are at this point are smaller scale, but in 10 years from now, 20 years, these might be more of the norm and integrated into our society as far as, in this instance, how or where our food comes from and how our food is grown. Because we have more and more people and we need more land in order to grow more food to feed people. And the more people we have, the less land that is available. So what do we do? There is this really interesting endeavor that is called vertical farming. And what you see in the lower pictures is that people imagine that every city, town will have, like at the center of it, just a skyscraper, which basically all it is are growing plants. Because you think of the way it works now is that we grow crops horizontally, which uses lots of ground. But if you grow plants vertically, you can have the same amount of crops in a very small space. It's kind of the same, reasoning behind high-rise buildings as far as housing people. If you have to house 1,000 people and they're all just one-floor apartments, it's a lot of land, but you build up and you can put them in a smaller space. So vertical farming, and this isn't all, vertical farming isn't like completely hypothetical. There are vertical farms that exist today. Another, which is somewhat experimental, is that a lot of the crops that we grow have to be planted every year. You think of corn and you think of wheat. The farmers plant these, like they plant them every year, they harvest them, they remove the plants, and they get bare soil, and then they have to seed the land every year. And that is those types of plants that you have to plant every year is called an annual. Perennial plants are those that just come back on their own year to year, like apple trees or most trees, or like apple trees you don't have to replant an apple tree every year. It just produces apples every year. The plant might live for, decades, and every year apples are produced. It just grows, it's dormant over the winter and then just regrows in the spring and the summer, like your lawn. You don't have to reseed your lawn every single year. It just grows every year on its own. And so they're developing the grain crops, which are perennials. Once you plant them, they just grow every year and produce the crop. There is a wheat that is called kernza, which is it's a perennial. It you don't have to replant every year. It just keeps growing back every year, which, once you think about it, that makes a whole lot of sense. Boy, wouldn't that like be so much less labor intensive than having to plow and seed every year? And so far it's still in the experimental stages, developing these normally annual plants to being perennials. And you see the Cascadian farm it's experimental, kind of organic, the word I'm thinking of, place, company, and they've been experimenting with kernza being used as a breakfast cereal. So who knows? I know some of you who want to be involved in the environment. Food science is a huge, huge field because we all need to eat. And so finding solutions to feeding people of the world in a sustainable way, in an environmental friendly way, is certainly the challenge of our future. That is it. And I hope you enjoyed that. And all right. Okay. Take care, everyone. See you later. Bye.